All right, let's get started with polynomial long division. So, long division. Hopefully by now you are very good at doing long division. Maybe you haven't done it in a while, but you should remember how to do it. So what we're going to do is do this very easy long division problem right here alongside a long division problem with polynomials. So you notice that we write it the same way. This is 198 divided by 6, so we can say that as 6 into 198. That's the way we would say it with this little representation here. So here we're dividing x squared plus 8x plus 15 divided by x plus 3. So this is x plus 3 into x squared plus 8x plus 15. So we're going to learn how to do polynomial long division by showing that it's exactly the same as doing it with numbers. So the first step here is we would say, can 6 go divide into 1? And it cannot. So then we look at the two digits here. Can 6 divide into 19? Yes, it can. It can go into 19 3 times. So we put a 3 up there. So now we're going to do the same thing over here, except the only difference is with this x plus 3, we're only going to look at the first part, first term here. We're just looking at the x. Ignore the plus 3. So can the x divide into x squared? Yes, it can. X times what equals x squared? X times x equals x squared. So we put an x up there. Now the next step is we multiply these two numbers and then subtract it from this number here. We call that the dividend, the number that we are starting with. So we multiply these two numbers and we get 6 times 3 is 18. Then we subtract 19 minus 18 and we get 1. So now we're going to do the same thing here. X, multiply that. Now we're going to multiply by this whole thing. This, by the way, in case you forgot, is called the divisor, the number we are dividing into. So x times x is x squared, and x times 3 is 3x. And now we subtract. X squared minus x squared equals 0, so the x squares disappear. 8x minus 3x equals 5x. And now we repeat the process. First, we're going to bring down the 8 here. 6 goes into 18 3 times. 3 times 6 is 18. We subtract, and we get 0, so that means there's no remainder. Same thing here. Bring down the 15. Just looking at the x again, just the first term. X goes into 5x 5 times. So put a 5 up there. 5 times x is 5x. 5 times 3 is 15. We subtract. We're again left with 0, which means no remainder. So there we have it. 198 divided by 6 is 33. And x squared plus 8 plus 15 divided by x plus 3 equals x plus 5. So that's our first long division problem with polynomials. And you can see that it's pretty similar to how we normally do it. Now what you should realize here is that the dividend here, x squared plus 8x plus 15, is a quadratic. And we know that with this quadratic, we can easily factor this. What are two numbers that multiply to 15 and add to 8? That's 5 and 3. And look at that. When we factor this quadratic, we end up with these two terms that are the same here. Here we showed that x plus 5 times x plus 3 equals the dividend. And here we've shown that as well, because the dividend divided by x plus 3 equals x plus 5, which means if we were to multiply them together, we would get back to the original dividend. So it's the same thing. Polynomial long division with a problem like this is the same as factoring. we basically were just given one of the roots already. We find the roots by setting the equation equal to 0 and seeing what x needs to be. So in this problem, x needs to be -3 or -5. So what we're basically given here is x squared plus 8x plus 15 equals 0. One of the roots is -3, so find the other root, and it's -5. So we're basically just, polynomial long division is yet another way to find roots of a quadratic. So let's do it in that exact way. We have another quadratic here that we could very easily factor, but we want to find the roots using long division. So if we know that one of the roots is -2, then what is the other root? Well, we have to think, how do we create a term out of a root of -2? Well, it's always the opposite sign. We're going to have x plus 2 equals 0. This would make x equal to -2. So one of the roots is going to be x plus 2. So x squared minus 8x minus 20, we're going to divide that by x plus 2. So we're finding what root times the root of x plus 2, what term times x plus 2 will get us back to the original equation. So let's perform the polynomial long division. X goes into x squared x times x plus 2 is x squared plus 2x. We subtract, x squareds disappear, -8x minus 2x is -10x. Bring down the -20, x goes into -10x, -10 times. We multiply -10 times x plus 2, and we're going to get -10x minus 20. Remainder of 0, so we have the root of x minus 10. So that means that, what is this other root here? Well, if x minus 10 equals 0, we find the root. What does x have to be to get the equation equal to 0? X has to be 10. So the missing root is 10. Okay, let's do another quadratic example. We will do non-quadratic examples later in this video as well. So this time we're going to be given a root of -2/3 and have to find the other one. So how do we create a term out of -2/3? If x equals -2/3, then let's move to the other side. So x plus 2/3 will have to equal 0. But what we don't want to do is have a divisor here with a fraction in it. So what we can do is multiply both sides of this equation by 3 in order to get rid of the denominator. So we'll have 3x plus 2 equals 0. 0 times anything is obviously still 0. So this is actually the divisor here that we're going to divide the equation by. So now let's go ahead and do that. So we're going to divide 3x plus 2 into 3x squared minus 10x minus 8. So 3x goes into 3x squared, x times 3x plus 2 is 3x plus 2x. We subtract, we're going to get -12x, bring down the -8. And here, let's see if we can skip a step here. 3x plus 2 times what is -12x minus 8. You should see that the whole thing is just needs to be multiplied by -4, and then -4 times that will give us -12x minus 8, which means when we subtract, we will get 0, so we don't even have to bother with that step. We have our root here. We have our term here of x minus 4. If we set that equal to 0, what is the root for x? X would need to be 4. So there's our answer. Okay, one last quadratic example. So there's our equation, and we're going to be given 1 root of -7. So what is the other root? Now in this case, it might actually be faster using polynomial long division than factoring this, because this looks like kind of a hard factoring problem, right? Well, the first thing we want to do is actually factor something out of this equation. You can see that all the coefficients can be divided by 2. So actually, you know what, instead of factoring out a 2, we can just divide the 0 by the 2. So if we're dividing both sides, then we don't even need to worry about factoring out the 2. We can just divide it out. So now to create a term out of x equals -7, we can say x plus 7 equals 0. So we're dividing by x plus 7. Okay, let's just run through this problem real quick. X into 2x squared is 2x. Multiply that by the divisor. Subtract. X plus 7 times what gets us to here? Just look, x times what is -3? It's -3. So there we go. It's 2x minus 3. Set that equal to 0. And what does x have to be? X has to be 3 over 2. 2 times 3 over 2 is 3. And minus 3 will equal 0. So the missing root was 3 over 2. In fact, what that shows us is this problem was actually not even factorable, because remember, factoring only works when you have integer roots. So this one we actually would have had to do completing the square or quadratic formula, which would take much longer. So this is actually a new fastest method for quadratics. But the thing is, it only works when you're given one of the roots to start with. The other methods are for when you don't know either roots and you have to find them both. Okay, but all of that is going to change once we bring in higher degree expressions. So here we have a cubic function. And so, at least for right now, we can only do this when there's only one root that we're missing. Because when we divide, we're just given one term, which provides us with the missing root. So here we have this cubic function, and we have 2 roots that were given. So we have 2 options here. We can either divide this whole thing by, this will be x minus 2 to give us the root of 2, and this will be x plus 5 to give us the root of -5. So the 2 options are, we can either divide this whole thing by x minus 2, and then divide the result of that by x plus 5. Or the other option, which is going to be faster, is to create a quadratic divisor. So that means take the 2 root terms that were given and multiply them out to get x squared plus 3x minus 10. And now we can just divide this quadratic into here. It's going to be a little bit harder of a division problem, but it is going to save us steps. So let's take a look now. Make sure we have enough room. Let's take a look at what happens when we have a quadratic divisor. It's the same thing. You only look at the first term of the divisor and the first term of the dividend. X squared goes into x cubed how many times? It goes into it x times. And now we multiply this whole thing by x. That's not bad. We just increase all of the exponents by 1. Now the trick is, when we subtract, we have to remember to subtract both of these. So 2 minus 3 will be negative x squared, and negative 13 minus negative 10 is negative 13 plus 10. So that'll leave us with negative 3x. Bring down the 10, and look at that. We can see that this is just this negated, which means we multiply by -1. We would end up with this being subtracted from itself, which is 0. So x minus 1 is the quotient that we are left with. Set it equal to 0, and x is 1. So 1 is the missing root. So now we have all three roots of this cubic function, 2, -5, and 1. Okay, let's take a look at another cubic function here. Now the difference with this one is I'm only going to give you, this time, I'm only going to give you 1 out of the 3 roots. So this is not going to give us the answer when we divide by the one root, the one term we can create of this root. But it is still going to allow us to find the 2 missing roots, and you will see how. First thing we have to do is create a term out of this root of x equals 4/5. So if x equals 4/5, x minus 4/5 will be 0. And now we multiply to get rid of the denominator. So 5x minus 4, that's the term we're going to be dividing this whole thing by. Okay, this is kind of a long one, so let's go through it. 5x into 15x cubed, that's going to be, if you're having trouble right away, just look at each one separately. 5 into 15 is 3. X into x cubed is x squared. And now we multiply by the divisor. Subtract. And remember, we only bring down the next term, not the minus 8. So 5x into negative 35x squared is going to be negative 7x. We multiply that out. Subtract, we're going to get 10x. Now we bring down the minus 8. And this is 2 times that. So plus 2. Okay, so we're left with a quotient that is a quadratic. So we still don't know either of the missing roots. What we actually have to do now is factor this quadratic, or if that doesn't work, we go to completing the square or quadratic formula. But we can't use polynomial division because we're only given one root and we already divided using that root. So there's no roots left to use, there's nothing left to divide by. So we have to go back to our traditional quadratic root solving method. So we're actually going to, this one is factorable. We're going to do our x method here in order to create 2 terms, like so. And from here we find the missing roots are 2 and 1/3. So those are the missing roots right there. So the roots are 4/5, 2, and 1/3. Those are the 3 roots here. Now let's just do one other thing with this problem, just so you see how, if we want to actually, instead of just getting the roots, actually put the whole equation in root form, let's just make sure we know how to do that. So here we have 5x minus 4. That's one term we created out of the 4/5 root. From 2, we'll create x minus. And now with this root of 1/3, we wouldn't want to have a fraction. So we would, instead of saying x minus 1/3 for a term here, we would multiply both sides by 3 and get 3x minus 1. So that's what we're going to put in here. So this is the root form of this equation. And what you want to check to make sure, your leading coefficients match up. So what we're going to do here is just multiply the coefficients of the first term in all of these groups. So 5 times 1 times 3 is 15, and that matches up with the original. So that shows you that you have all your coefficients lined up. And the reason that's important is because, as we're going to see in the next unit when we start graphing, if we were to graph with the wrong coefficients, if they still produce the correct roots, the graph would still look pretty similar. But the heights and some of the steepness of the curves and all of that is going to be way off if the coefficients are not exactly right. So that's important as well. Okay, for our last problem, we're going to take a look at a quartic function, meaning the highest degree is 4 now. And again, I'm only going to give you one root. And if you're wondering how that's possible, because it means we're going to be left with a cubic function, how do we get roots from that? If you're not seeing how this is going to work, think back to the last few videos, and you might think of the answer. But regardless, you're going to see it in just a minute anyway. First thing we have to do is create a term out of this. Instead of x minus 1/3, we're going to have 3x minus 1. That's what we're dividing this whole thing into. Okay, 3x into negative 24x to the 4th is negative 8x cubed. Three x into 60x cubed is 20x squared. Sorry, I forgot to bring down the negative 14x squared there. Okay. 3x into 6x squared is 2x. And we have to bring down that plus 5 somewhere, okay? 3x into negative 15x is negative 5. Let's just finish this one out to prove that we do get 0 as a remainder. Okay, so we're left with a cubic quotient here. So what do we do with this? Well, we have to think. We can't use division because we're only given one root. We already did that. So the next thing to think of is, can we factor it? And the answer is yes, we can. In the last video, we looked at how to factor higher degree functions with 4 or more terms, and we used the grouping method. So let's rewrite this over here. What you should notice is that 2 times 5 over 2 is 5, and 8 times 5 over 2 is 20. So this looks like it's going to work. We say, what can we factor out of the first two terms? We can factor out negative 4x squared. And we'll be left with x. We'll be left with 2x minus 5. And what can we factor out of here? We can factor out nothing, which means we'll also be left with 2x minus 5. So now we have roots here of 1 minus 4x squared and 2x minus 5. We have terms of these here. This is, of course, set equal to 0 if we're finding roots. So 2x minus 5 set equal to 0. X will be 5 over 2. 1 minus 4x squared set equal to 0. Well, this is a little bit different. If 1 minus 4x squared is 0, then we move the negative 4, we move the 1 to the other side. Negative 4x squared will equal negative 1. So now we're going to have to finish off this equation here. X squared will equal 1/4. And now we can take the square root of both sides. The square root of 1/4 will be 1 over the square root of 4, which is 2. But remember, it's plus or minus 2. So this x is actually plus or minus 1/2. So the roots that we have here are 1/3, 5/2, positive 1/2, and negative 1/2. Those are the 4 roots of the quartic function. Remember that you always need as many roots as there are degrees here. The degree is 4. Okay, this is our first video on dividing with polynomials. We're going to be basically doing the same concept for the next several videos.